Yesterday we did vertical translations. And if you really got it at the end, hopefully you're like, I'm unimpressed, Mr. Todd. I'm liking that it was a pretty easy lesson, but geez, I think you spoke for 40 minutes yesterday, Mr. Todd, and all you said was, if there's an add outside, it moves up, and if it's subtract, it moves down. Well, I was also reviewing root x and 1 over x in the meantime, okay? So then when the title comes up today, horizontal translations, hopefully that triggers you like, oh, instead of up, down, we're going to talk about left and right. This is going to be easy. It's 90% easy. It is. 90% of what I'm going to talk about today is real easy, but there's one little thing I got to talk about here that's going to be a little awkward. So, to do horizontal translations, we start with an investigation. How do the graphs of y equals root x plus 4, with the x plus 4 inside the root this time? That's how it's different than yesterday's. Yesterday the plus 4 would have been outside the root, and that changes everything, apparently. And y equals root x minus 2 compared to the graph of y equals root x. I stick to what I said. When stuck on something, in functions this class, advanced functions the next class, calculus the next class, when stuck, a table of values might help. Do we always want to do table of values? No, it's too slow. If we're always building table of values for everything, we're never going to get anything done. But when we're stuck, we can go, okay, let's build a table of values. For instance, hopefully by the time of the test, when you see y equals root x, you'll know what the graph looks like. Sorry, I'm just moving this around to fit on my screen better. And I've tried to maximize zoom on these so people could see easily. But let me ask you, if you were making a table of values for root x, would you use -3, -2, -1, 0, 1, 2, 3 now after what you've seen? No, it's a bad choice. You could do it. You could do it. But you'd find out that -3 is a bad choice for an x value. Square root of -3 isn't a value we can register. -2, -1. So what's the first one that we like on the table of values for root x? What's the lowest number we can take the square root of? 0. If somebody said 1, I would have said that was right too. I would, oh, I know what you mean. 1's the first one that is a regular number, a natural number, but really we can square root 0 and I get 0. Then 1 is the next one. Square root of 1 is 1. And you can use 2 if you want, but you're asking for a little bit of trouble when you do that. But it's not wrong to write 2. You could do 2. You could do 3. But what's the next one that's going to work nice? 4. Yeah? All the things that are squared are the ones that can square root. I hope that doesn't blow your mind. Square root of 4 is 2. Well, what's the next one? 9. Square root of 9 is 3. The next one? 16. And that's a 4. That's more than enough to graph. I might have made you on your assignment do more than that. So would you go up to 25? You did the next one too, right? And then it was like, the graph was like really wide. You're like, why are you making it? Why are you torturing us like this? Well, I wanted you to see it, the pattern. No, sorry, not the pattern, the trend. Yeah, the pattern is not maybe the right word here. Yeah. All right. Y equals root x plus 4. Different ball game here. We're going to really need to think here. Really think. This is how this one's different than yesterday. Yesterday there was no, I don't say there was no thinking, but there was no pressure on your brain here. What x value should I start with here? Esther Rose, I'm going to ask you in a second. But I just want everyone just to think for a minute and go, what's the first thing I can square root? And what does that lead me to for what x value would be the lowest x value I'd use? Okay, Esther Rose, I'm ready. What do you think? She likes -4. If you don't like -4, or you're like not sure where she got that from, watch what happens. Watch what she can see is going to happen here. If I use x value -4, then I'm finding square root of -4 plus 4. What's -4 plus 4? 0. See, she's very clever. That's the first one I can square root. If I went any lower with the negative, and this is one of the big ideas of this chapter, if I went any lower on that negative, I wouldn't have been able to take the square root. If you went -10 for example, negative 10 plus 4 is negative 6, I wouldn't have been able to do the square root. That's why she showed negative 4. Now that you see what she's up to, can you choose the next x value? That's going to give me a nice square root. Negative 3, someone says. Because negative 3 plus 4 is 1, and I can square root 1. Is that what this chapter is about, figuring out clever numbers? No, not at all. That's just what I'm using in this investigation. You know? So don't get sidetracked by that and go, I'm not good at this. That's not what we're really up to. That's just me trying to build a nice tidy table of values here. But what's the next one? If I want to do square root of 0, because that'll give me square root of 4 equals 2. Now, another level of clever here might be like, I'll just do all the numbers, and if I get decimals, I'll just skip them as I go. That totally works too. You don't need to be this clever. You don't need to be. You can go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and only use the numbers that come out to whole values. Yeah? So we might be being more clever than we have to be here. But just to continue on, what's the next root I want to get is 3. What x value is going to give 5 is the next one. Because then I get root 9 is 3. And again, if this is bothering you at all, don't let it bother you. Do all the x's then. Do all of them. It's fine. I'm just trying to build a tidy one. And what's the last one that's going to fill my table? 12, because 12 plus 4 is 16, and root 16 is 4. Now let's just jump ahead a little bit and actually finish this lesson. Actually. I mean, I'm going to blah, blah, blah for another 35 minutes because they're paying me for this. But the whole thing's about to happen right here. On the net graph, you got to, oh, you need graph paper. Ooh, graph paper. Oh, Mr. Yakimishin took all my graphs. Oh, and I just lectured some people yesterday about graphs. Not graphing on non-graph paper. That's important. I'm coming around. Hey, she's got the graph paper notebook. Go shopping this weekend, people. Go get some nice graph paper notebooks to do graphs on. You need graphs for graph paper. It matters now. You're like, never mattered before. I just drew little graphs and all worked out. No, no. Today, we need nice graph paper. Emma, it's good, Emma. Thank you. She got, ooh. Graph paper whenever you want. They got the iPads. That's what you're asking for Christmas, my friends. I would like an iPad. Just look over your shoulder and see what they're doing back there. It's like, whoa. No more carrying around all these books. Just me and my iPad going to class. If you're bougie, you'll get an iPad Air for no reason. Are those Airs back there or are those regular iPads?
Thank you.
It's a what? Mm-hmm. No. Well, no, the Air is, yeah, the Air is faster, better camera, all those things, but she's fine. You're good. You're good. Okay. Good job, Miss Todd. Hand out the graph paper. So, get your graph paper out, and we're going to graph these first two and actually finish the lesson. Really. First, we're going to graph root x on our graph paper. Here's the grid I chose. You should have lots of space. You can turn your graph paper sideways if you need to. Draw on two axes. Let's see, what was it? Ruler. Ruler, ruler, ruler. Look, they're Egyptian. No, that's not true. It's a joke. They're Egyptian rulers. They're rulers of Egypt. They're brand new. Brand new. Anybody else? Ruler? You take them out of their package. You throw the garbage in the garbage. Yes? Friends? The garbage goes in the garbage. Your dishes go in the dishwasher. A few life lessons going on here today on a Friday. What do you mean? What are you talking about dishes go in the dishwasher? I'd never put my dishes in the dishwasher. I know. Start putting your dishes in the dishwasher.
Can you tell Liam I want the best for him?
Are you guys going to start wrestling again?
He's trying on my arm.
No, no, I said I wanted to do well.
Nathan, don't understand.
I understand it, yo.
All right. After a slight delay, we're now ready. And those of you watching on a video, get some graph paper. Print it off your printer. Okay, first graph, y equals root x. I'm going to do the first one in orange, trying to motivate you that the base function that we're moving around, do it light. Yeah? You just want to barely see it. So here it was, 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. How did I do on the color choice? Can you just barely see the orange?
Very bright, actually.
It's very bright. So you can see it though. Well, once I do blue though, it should be, yeah. And connect them up. Okay, let's not get all mathy here. What is this thing? It's a parabola. It's just sideways half a parabola. If squared is a parabola, root x is also a parabola, but the other way around. The x and y have reversed roles here. So there's what we should get for y equals root x. And again, help again for your assignment that you're working on. Now, I'll give time to copy. You can stop me at any time in this lesson to copy. If you're only going to listen to 85 seconds of this lesson, here's the 85 seconds. So stop what you're doing and just watch what happens here. When you see square root of x plus 4, your brain, which loves to recognize patterns, goes, I know what's going to happen here. I know just what's going to happen here. If yesterday add moved up and subtract moved down, and now you're doing horizontal, add 4, it's going right, baby. That's easy. Hang on. Graph it and find out. First point, negative 4 comma 0. It's going left. Feel free to be mad. You can be like, geez, math. You couldn't, not once, you couldn't make my life easy once. Now it has to go different than what I thought it was going to go. I can explain it, and I will explain it in a second. I hope I give a great explanation of it. Negative 4, 0, and then the rest, it all falls into place. Negative 3, 1. It just moved left 4. 0, 2. 5, 3. And 12, 4. A bit of an optical illusion again. It looks like it's getting closer and closer together. And it sort of is. But it's not. If you look, everything's just been moved left 4. And because the function starts to grow so rapidly, it looks like it's moving together. Left 4. Lesson over. Really. You could go home and go, okay, well, the one inside the function does the opposite of what I thought it was going to do. I can explain that, but not very well in the video, because I like this demo in class. So sorry, video people. I'll try to narrate what I'm going to do here so that I can explain why it moves left. Okay? I need a volunteer to help me with a demo. No, Kyle's not here. Nathan, will you stand over here? Yep. And Nathan's standing on my right. Okay? Now face the board. Let's pretend it's the board is like a Just Dance routine.
Okay.
You don't have to do anything crazy because we don't want to break Mr. Todd's hips here or anything. So don't do anything. Just do some things.
Just like smart.
And notice I'm left of him, but I'm looking right. And I'm going to copy his moves. Let's say I don't know the Just Dance moves. This happens to me with my kids all the time. They're doing the dances and I'm falling behind. The first couple of moves, we'll do 3 or 4 moves.
Okay.
And just notice I'm looking right. Okay? Do you see? I'm looking right to copy him. A couple of dance moves. I'm already starting to hurt. We can't do much more of this. Yeah? Okay? Now, that's not the important part. Here's the math part. If I'm looking right, which way are the moves going? Do you already see what's happening here? I'm looking right, But if you were trying to see how I translate his moves, are they moving across the room right with me looking right? No, they're not. Go. Which way are they moving? See? I'm left of him looking right. If that bends your brain a little bit, yeah, I know. Thank you, Nathan. That's good. Sad. Those are the best moves we could come up with. And somebody's out there going, I could have done a lot better. You're taking it easy on me, were you?
Yeah.
Yeah, you're like, hey, there's no way he can do the... Yeah. Okay, hold on. In the table of values, y equals root x plus 4 was looking right. It was taking x values and adding 4 and going, I'm going to look to points that are right of me and copy them, making the graph move left. Why didn't that happen yesterday? Now that's a good question. What's actually happening is, notice the numbers are with the x. Yesterday the numbers weren't with the y, they were on the opposite side, so it's opposite. Okay, that's hurting my brain. Is it okay, Mr. Todd, if I just memorize? The up-down makes sense. The left-right is the opposite of what I think. I think that's what most students do in grade 11 and 12. They just go, inside the function does the opposite of what I think it's going to do, for some reason. But it's just this right-left thing. It's just saying it's looking right, so it must move left. Okay, let's do it all again, just in case that got a little fuzzy on you. Root x minus 2. What do you think? Can you already make the prediction? Yeah, if you can already make a prediction, you can go home. No, you can't, but mentally you can probably go home. What's minus 2 going to do? If plus 4 moved it left, it's going to move right, less than over. I mean, I got a few details to tell you, but that's basically what we're going to finish off with today. So root x minus 2. Oh, let's not, actually, I take it back. Let's not be clever, just in case the cleverness messed anybody up. Right here, I'm going to do the not very clever table of values so that you know it's okay. You don't have to be that clever. You might plug in -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Here's the weakness of the not clever method. You got to write down a lot of x values to find out what the good ones are. So I'll write the bad ones in red, and when we get to good ones, I'll write them in blue. This would be square root -3 minus 2 is -5. No good. Yeah? This one's square root -4, no good. This is square root -3, no good. Do you see why this will accomplish what we're after? But it's not, it has no cleverness whatsoever to it. What's the first one that we can actually do here? -2, no. -1, no. Square root, oh, there's the one. That should have been in blue. 2 minus 2 is 0. There's the first really good point for my table. So I'll put it onto my clever table. This chapter is not about being clever, let me tell you. This is not the game we're trying to play. I'm just trying to save you some work and going, hey, can I make a better table of values right out the heart? So then you try and sub in 3, and that works out too. That becomes square root 3 minus 2, which is root 1, which is 1. So that's a good value to use. Root 1, which is 1. That's perfectly good. But watch what happens with 4. Root 2, 1.4. You could totally use it. 1.4 right about there, you know, between 1 and 2. Yeah. Sneering face up here in the front row. A couple people are like, oh, no good. Yeah, we don't want the decimals. Root 5. That'll be root 3. No, 1.7. Sneer, right? Ugh. 6. Root 4 is 2. That's one I should use. 6 will give root 4, which will give 2. I'll do the rest clever-wise. You can keep going like this until you got the clever ones. What's the next clever one? What's the next number I should use? 11 will give me root 9, which is 3. 18 will, yeah, you're getting the idea now. But I don't want you to think that we have to be that clever. We don't have to be. we can just keep putting x values in this chapter. Okay? Now I go to my graph. You've got graph paper, yes? She's got graph paper. Yeah, okay. Built-in graph paper. Here they go. 2, 0. 3, 1. 6, 2. Also my height. 11, 3. And 18, 4. There's an optical illusion going on here, making it look like they're getting closer and closer together, which they are, but what's actually happening here? Take a look at that graph versus the orange one, which is supposed to be my light one. What did it do? It moved right to it. You're less than surprised because of the way I taught it. So how I can now say this right here, left 4. This one, right 2. Lesson over. No, not quite. I got a few details, but if you get that, you're home free. Nothing harder than that on a Friday.
Was that the only hard part?
Yeah, was the opposite of what we thought. That was the big surprise. Yeah, like it was like 10% of a problem. The one inside the function does the opposite of what you might expect it to do. What is the domain and range of each function? Oh, okay, all the domain stuff again. So let's do domain and range of y equals root x. And we'll do domain and range of y equals root x plus 4. That was the second function. And the third one was y equals root x minus 2. And let's talk about the domain and range of those three things. Domain of root x. Are all x's allowed for root x? Anything above or including 0. So when you say above 0, that's that.
I normally do the line underneath it.
Yeah, right, yeah. Greater than or equal to 0. And the range is also
It's just one.
YER such that also greater than or equal to 0. Remember I said the lesson was basically over. I hope that this is less than exciting, what I'm about to write here. All that happens when you move it left 4 is the domain moves left 4. X element of reals such that x is now greater than or equal to negative 4 because it's been moved left 4. The range stays the same.
I just have a question.
Fire at will.
Does it matter, like when you're putting the domain, does it matter if you put the negative 4 before the x?
Do you know who Yoda is?
Yeah.
After that whole Mandalorian thing, maybe people are confused about who the original Yoda was. The original Yoda spoke weird. They made him weird on purpose. They gave him a funny voice. He was a funny Muppet-looking deal. But he spoke weird. He's supposed to be wise and ancient. So they gave him a funny method of talking. He spoke like this. Like if something happened that was scary, I would say, Mr. Todd would say, I am scared. Yoda always did it backwards. He'd say, scared am I. He'd say to Luke, scared am I, like that. And you listen to it, you're like, what? Why are you talking like that? It's weird. I get what you're saying, but it's weird. And if you put the variable second, mathematicians would be like, it's not wrong, but why are you doing that to us? If we can, we put the variable first. But not unlike grade 9. In grade 9, the answer 4 equals x is technically correct, but everybody looks at you like, what? Why are you writing it? X equals 4. That's how we're used to writing it. So not wrong. I marked it right. A bunch of people did in the quiz, and I marked it right. And I didn't circle it or anything. I just went, yeah, it's all right. Okay, domain of this one. This one got moved right to, so now its domain got moved right to. That's all. And the range stayed the same. How could the range change? What would have had to happen for there to be a range change?
There would have to be a plus or a minus outside of the...
That vertical translation. So we're about to put those two things together in just a minute. That's all that's new after this in this lesson. Is there any questions about that? As I randomly switched to red for some reason. I meant to write in blue today, but I randomly switched to red somewhere in there. I don't have to ask if there's more time. I can still see people madly writing, so I'll just wait for a second.
Yeah, your parents took it away the whole day.
Oh, is the phone back?
It is back, Mr. Todd.
How did it get back?
I don't know. I'm happy though.
Not strict enough. My parents were
Because
lost.
I don't want to go all teacher-wise on you here, but
It's because I got home and I did my homework right away.
your parents are wise.
Pity.
Your parents are wise. But if you're going to be wise now, you're going to be like, now that I have my phone, now I'm going to kick butt.
Yeah.
As opposed to the other way. Like, I have 4 kids. 3 of them are proactive. They get ahead of the game. They've learned. Let's be a step ahead. Let's do stuff right so we don't get in trouble. My last one is reactive, and it's a pain. Let me tell you. Little Bennett, oh boy. Yeah? He does stuff until he gets in trouble. Then he corrects, as opposed to going, or Chloe's the opposite. It was like, no, I don't want to get in trouble. So she tries to follow the rules. But boy, it's tough life. And when you're 7, it's okay. We take care of you. But when you guys 15 now? 16 now? It's time to be proactive, not reactive. Let's avoid trouble. Let's not wait till we get in trouble to fix our behavior. Yeah? Did I buy you enough time? Everybody's good? More time? Good? All right, well, you're going to be less than enthused about this slide. In general, here's the memorization tool. Here's what you write down when you're trying to study this and memorize it. For a graph of y equals x minus h, if h is greater than 0, it goes to the right. If h is less than 0, it goes to the left. This is somebody trying to be super clever here about writing this down. See, they put a negative here. So a negative positive would go right. However, if you're like, I understood it better a second ago. Negative goes right, positive goes left. That's all this is saying. It's saying the same thing, just with some fancy symbols. Now, if you look at the boards, you can't see it on the video. You look at the boards, do you see what they're up to in calculus? Look at these crazy symbols. To do the math in calculus, we need some crazy symbols to knock it down. Is it time for that yet? No. But we introduce it here. We start going, let's just put some symbols in there of what's going on there so we can manage these situations. This is just saying, if the number in there is negative something, it goes right. If it's positive something, it goes left. But this is just saying it in fancy symbols. Do not let this slide derail you or your understanding of the situation. Because again, the whole lesson is negative right, positive left, get your stuff and go home, have a good weekend. Yes, that is the main part of the lesson.
That wasn't it. No, it wasn't.
I also have an updated mark for you today too, so that'll help. Yeah, maybe they'll give you some Apple dollars. What are they called? Apple money. You don't even know. You just hooked up to your parents' credit card, so you're just like whatever.
Well, I just have mine.
Oh, okay. It used to be a big deal. Getting an Apple gift card was like, woo, can buy some apps. Now it's like iTunes gift card, right?
You know, we used to
Yeah.
spend on
Oh,
songs.
iTunes used to go crazy.
I used to have 3 songs, paid for all 3.
Minecraft
More time here?
Edition went hard.
I gotta lose.
Yeah, more time.
Yeah, oh my
Am I doing better on the Zoom? Is it big enough today?
bucks the next year. I was like, fuck yeah.
It's okay.
It's my turn. I just said it way louder.
Did you not say way louder? Did you say way louder?
I said it. Yes, I did.
Kyle's back.
I said it properly. I said it louder. I said it.
All right. I'm looking forward to marking it.
Why do you mark it?
Tonight. No, this weekend.
I won the game. I won the game. Wrap it up.
Thank you.
Wrap it up. Wrap it up.
You gotta go again.
Nope.
You have to go.
It's his turn.
Carter's the judge.
I'm not going twice. Carter's not the judge. Carter's not even playing.
Carter's the judge.
No, he's not.
I'm not playing because it's the judge.
Nope.
It's your turn. Yeah, it's your turn.
I just said it louder and clearer.
Mine was way louder, first of all. And you said dirt.
Are we good?
This guy's so loud.
Okay.
It's not like it.
Here's the whole deal. A review of yesterday's and today's lesson, comparing vertical and horizontal. When the k is outside the function, positive up is negative is down. When h is inside the function, see there's a negative there? You got to reverse your thinking. That's what that negative is there for. You're like, why are they writing a negative there? Are you just trying to mess me up? I was thinking I understood this lesson, and now you're putting a negative in there to mess me up. No, I'm actually trying to help. The negative in there is a hint to going, reverse the thinking. Inside the brackets, negative goes right, positive goes left. You're like, that's a whole nother slide saying the same thing there, Mr. Todd. No, this slide's better. This slide has everything all in one. So when you're going back to look at this is the one that gets the red box in your notes or the yellow highlighter or something like, here, what do I need to know from these 2 days of transformations? There. Hey, stop that. No, move this over there. Minimize that. Uh-oh, uh-oh. There it goes. Kyle.
What's with the y equals though? Is that just like,
It means whatever function you're talking about. So the first functions we talked about, and I'm coming right back here, if I know you here, y equals whatever. Whatever function you're talking about. So whatever function you're talking about, if you see a plus out here, positive means up, negative means down.
He said it louder, but not as clear. Doesn't matter, said it.
wait, but that doesn't make sense. Like, what does that look like?
Shut up.
Go ahead and ask your question.
No, like, what is it like? When it's like written out as a function, so you add like how we were doing, like where you.
Yeah, the f of x might be like, maybe it's root x there. Like when we write f of x, we don't necessarily mean some random thing. We're saying whatever you're talking about. Maybe you're doing question 7 in the homework, and that's a root x in there.
Yeah.
Maybe Nathan's doing question 2 in the homework, and that's a 1 over x there. But the thinking's the same, though. Whether you're doing root x or 1 over x, that plus k means it's outside the function. So here's 2 different examples of that top thing. Maybe you're doing root x plus 5. And maybe he's doing y equals 1 over x plus 5.
Yeah.
The point of this is saying whether you're doing root x plus 5 or 1 over x plus 5, the plus 5 moves, take your function and move it up 5. So that f of x is just a placeholder to say whatever function you're talking about.
Oh, okay. And then the plus k is.
Yeah, like whatever number it is in your question. Yeah, the 5 is like move up 5. Maybe it's negative 2, which would be down 2.
Oh.
Is your stuff in your?
Oh wait, no, it's not in here. Never mind. Never mind.
You're good?
Yeah, I'm good.
All right. More time on that slide? Are we okay? Hazel's on her phone. She must be okay. You're okay?
Yeah.
Anybody else? More time? Yeah? I'm not trying to rush you, but I'm also trying not to bore you.
Mr. Todd, what's a mapping notation?
What's a mapping notation?
No, it's like, no, I literally aced every single question, except like the last one I was a little confused about though. Like, I don't even know what that was.
You know what, Kyle, I'll start to do is, like when you're away for a lesson,
I was suspended yesterday. So
I'll make a video, and I'll put it online. That way, when you're
We didn't even worry about math.
but we didn't learn about that yesterday, so it doesn't make sense.
So
No, I know, but like, I'm not. I was.
No, that's what I'm saying. If you're in class, if you decide to play on your phone the whole time and not copy anything down, then go home and watch the video so you have a clue.
No, Mr. I'm stepping my game up. I got.
I'm looking forward to it. Nothing will make me happier. Nothing will make me
But
happier.
like quickly, like what is a mapping foundation? Just
Interrupt my lesson
like. Sorry.
to talk to you individually. Is that what you want me to do?
No, sorry.
Oh, no, yeah, okay. I'll do this. Glad to talk to you.
Fair enough, yeah.
The other thing I'll do is I'll make a math help room.
You do that though. Oh, I see what this is with these like.
Yeah, I know, yeah.
I'm sorry to pick up on it.
Yeah, it's good. I'm glad. Nothing's gonna make me happier. That's why I come to this job. Yeah, I come to this job to help people wake up. Yeah, in a good way. I know woke has got a bad name, which is ridiculous. Woke, wake up. Start acting like people. More time here? Did me and Kyle kill enough time for you? That's good. Okay, enough with the ideas, Mr. Todd. Show me what this is going to look like. What do I have to be able to do? Here's what you got to be able to do.
Hey, boys, come on.
Here we go. I know, we had time there. This says sketch y equals x minus 3 squared. Here's what you're going to need to be able to do. When you see y equals x minus 3 squared, you don't panic. To yourself, you go over here. I'm doing it in orange. For you, you're just doing it in a light pencil. You're like, this isn't the answer, but I'm going to graph y equals x squared. And maybe you're so good at y equals x squared, hopefully you get so good at y equals x squared, that you don't need a table of values. In fact, I'll do it sort of both ways. I'll make the graph while doing the table of values in my head. Really, it's not that bad. If I use x equals 0, what's 0 squared?
0.
What's 1 squared?
1.
What's 2 squared?
2.
4.
Oh,
What's 3 squared?
9.
9.
16.
16 goes right off the page, which seems like useless information, but it's not. It just tells me this thing goes right off like that. You're like, I'm not there, that is too fast for me. Build a table of values. I like it. I do. What about negative 1 squared?
1.
1. Negative 2 squared?
4.
4. Negative 3 squared? 9. Yeah.
Oh, it's a parabola.
It's a parabola. And follows the 1, 3, 5 pattern, by the way, if that's bouncing around in your head. Somehow, some way, parabolas follow the 1, 3, 5 pattern. Okay? That's what you should do first. Graph the base function. I read y equals x minus 3 squared, and I went, oh, we're talking about y equals x squared, but something's happened. Now we need somebody who's been paying attention and is right with us.
It's just you started at -3 instead of 0.
He says we started at -3 instead of 0. Hold on. The -3 in the brackets is inside the function. That decides right or left.
That's right. That's right.
It's right. So here, there's today's lesson right there. Right 3. Counterintuitive. With -3, you'd think it would go left, but it doesn't. It goes right. So you just take all these points and you go, move that point right 3, move that point right 3, move that point right 3, move that point right 3. Some people love this. Some people, this is the favorite thing in math in high school ever, is just moving these things around. Right 3, boom. And you just take all these points and you move them right 3. Do you see why I said to do the first one lightly, though? Things can get confusing if you're not careful. If it looks weird, finish the curve off, and can you see that that thing has been moved right 3? And again, if you're confused by the right 3, just imagine the red one is looking at the orange one to copy it. It's looking left, causing it to move to the right. That might give you a headache just a little bit.
Oh, but the other one.
Let's do a little better. This one says y equals x plus 2 squared minus 4. Let's actually think about what transformations have gone on here. Which one's the easier one? The plus 2 or the minus 4? Like, which one's the intuitive one? The one you look at and go, that's easy. The minus 4 is the easier one. What does minus 4 do? It's intuitive. Down 4. I wrote it second just because left or right, whatever, but you can write it first. It doesn't matter. And the plus 2 goes left 2. So I just take them all and move them left 2 and down 4? That's all? Absolutely. And I'm going to change to blue. Some people love this. Some people think this is their favorite part of math. You just take all the points, go left 2, down 4. Here I go. Left 2, down 4. Take this point, left 2, down 1, 2, 3, 4. Good. Take this point, left 2, down 1, 2, 3, 4. Take this point, left 2, down 1, 2, 3, 4. Like that. This point goes left 2, down 4. Separate colors maybe. Some of you are like, I can't write it light and dark enough. It's messing me up in my graph paper. I'm with you. I'm totally with you. You may want some pencil crayons for this. Where was I? Left 2, down 4. Left 2, down 4. Sometimes it doesn't look right until you finish the whole curve off. Does it now look like I went left 2, down 4? Now, if you didn't use different colors, like I have, you better label them when it's over. There's y equals x squared. What did I do? I did that one in red, right? Y equals x minus 3 squared. Relax, everybody. It'll be okay. You're going to be okay. I promise.
It's like cupcakes.
I need to excuse myself.
It reeks.
I think the most you're ever getting on one piece of graph paper is 3 graphs. By the time you put 3 graphs in there, it's just too crowded. You might even think that 2's too many.
You can do 4.
Yeah. But again, we're going to do a lot of graphing the next little while. It's worth it to head over to Walmart and get yourself one of these graph paper notebooks. These are nice. You open it up, it's all graph paper. If you got algebra to do, you do it on the graph paper. Then when you got a graph, you're ready to go. Does anyone have a bougie 5-star one with the fancy cover? Oh, okay. You want one that's got some style to it. Go over to Staples and get the one that's 5-star. And it's got different colors, and that's beautiful inside. Nobody has it? Oh, can I borrow it? Emma's got it. There you go. Now you're cool. Yes, when you got one of these. Still graph paper inside, little pocket in the front there, and different colors for your different classes. Fun stuff. Or you've got your iPad. What? When I finish the lesson.
Oh, I thought it was that.
No, I'm on slide 5 of 7. Do you need more time here to copy this down, Nathan?
Nathan's not copying.
Maybe I should email your parents. Wouldn't that be hilarious?
I think you should say Nathan's not copying the notes.
I noticed Nathan's not copying notes in class. I wonder if he's getting distracted by his phone.
That would be insane. That would be
You're
insane.
having too much fun here, man.
I enjoy people's pain. You got to enjoy people's pain. Don't let him watch the video. Hey, don't let him watch the video now because they actually said your name in the video. You're like, what are these videos Mr. Todd does? Oh, take a look at this. No!
Hey, I was an example though.
Yeah, you were a good example there. Yeah. Did I buy you enough time here? Are you okay? You need more time? You okay? It's okay. These ones don't say to graph it. It just says, and this f at x can mess you up. It's like, well, what's f? You're like, no, I'm just saying, whatever function you're doing, if there's a +7 out there and a -7 inside, what 2 transformations are going on here? There's 2 things happening. Palmer. He's all over it. He says right 5,
Yes, sir, Paul.
up 7. The one inside, counterintuitive. The one outside, intuitive. Yeah?
Left 2, down 8.
Left 2, down 8. If you're finding this super easy, I know. But right now we're juggling 2 things. So when you're learning to juggle, right? At first things seem okay. I've got some random clips here. Yes? When you're first learning to juggle, here's what it looks like. You're juggling 2 things. It's so easy. Oh, I could do this all day. You can even do it in the produce department with cucumbers or oranges. And you're like, I'm so good at juggling. And then somebody says, oh, what about 3?
No, Shaw, you're doing great.
Yeah? That's what's going to happen in this chapter. Right now we're juggling two things. It doesn't seem too bad. But later on we're going to be juggling three. And then suddenly things get a little bit difficult, right? I've never tried that before. It's actually pretty easy. Have you ever tried it?
Four of them, Mr. Tall?
No, I can't juggle four. See, as we're going to find out. Can you juggle three? And they'll say, can you juggle four? No, I can't do it. That's the first time I've tried three. Maybe tomorrow I'll try four.
No way. That's
You're starting to catch on. Mr. Todd, I don't think he's the most honest guy I've ever met.
Enjoys people's pains. That's like
Yeah, yeah,
crazy.
yeah. Is this okay? Do you have questions? That's what all those other slides are trying to say. Intuitive, counterintuitive. Does the opposite of what you think. I mean, Nathan's little demo was supposed to help with that. I look right, I must move left.
Nathan, that's from slide 2.
More time?
Where's the rest of it?
No, this is pretty easy.
Yeah.
Nathan needs
More time?
to put his down.
It's okay.
I will. Just
More time? More time.
Nathan needs more.
Oh, I got to pull all my stuff away here. See, you people on the video didn't get to see me actually juggle there.
let's get a chant going. I say Sam.
Sorry.
I'm missing it too. I don't understand. What sound is it?
Oh, you grabbed a photo, then copy. I thought you were looking on the website the other day, like using the website to copy when you're filming, because some of it's on the website. Are we good? Caught up? Everybody's good? It's good? Okay. Last one. Okay, look carefully what I'm going to do here, okay?
Okay.
Watch this. I'm going to try to do the question without the graph. And by the end, you might convince yourself, like, no, I'm not doing with these without a graph. Just show me the graph. So I'll do both, okay? I'm going to try and do this.
Y equals
Question.
1 over x.
Oh, Nathan wants a shot. Okay, hang on. Oh, hang on. The graph of y equals 1 over x is shifted 3 units left and 4 units down. Write the equation of the resulting graph. So y equals, let's do it in 2 parts, though. Let's just make sure we keep everybody with us.
Can you just get rid of it though?
No.
Hold on. Let's talk about the 4 units down. Where's the 4 units down going to appear in all this?
-4.
It's just over on the outside. Let's do that first, because you might get a tiny surprise here about where this other thing has to go.
Yeah, and you looked at mine and made sure.
No, I didn't. he's like making fun of you. I'm trying.
I would never do that. I would never make fun of you.
So it's brackets.
Oh, so it'd be +3.
So, okay, let's talk about that first. 3 units left plus 3.
3 facts.
It's got to go right with the x. That's what I want to say. It took me 20 years to phrase that in a good way. It's got to go right with the x. So you can put brackets if you want, but it's got to go right here with the x. And that looks weird, I know, but that's where it goes, with the x. It can't go outside the 1 over x. If I put it over here anywhere, put it in the numerator, it's not going with the x. It's got to go right with the x.
Oh, why is that facts?
Where's your 1 over?
But what's the point of this 1 over x then?
Harder, look at my domain and range. See how right it is?
No, but
That was the function. That was the question that they gave.
okay, yeah, but is it like 1 over anything? Just
X e r
whatever the denominator is?
then -3
No.
and y e r greater than
I'm not sure what you mean.
Like, what? Like 1 divided by 3 is 3.
No, this is 1 over x plus 3.
Okay, 1 over x plus 3 is.
Yeah.
The 1 isn't going to change the answer.
greater than or equal to.
Anything multiplied by 1 is.
No, this isn't multiplied by 1. This
I
is
mean,
1 divided by something.
Anything divided by. No, 1. I don't know what I'm saying, but.
I think you're thinking about anything divided by 1, it stays the same.
Yeah, yeah.
But 1 divided by anything doesn't stay the same.
Oh, it's 1 divided by anything.
Yeah, right, good. Okay, B.
So if the 1 was on the
Who's
bottom-
got this? Can anyone do the domain and range of the 1 over x function that's been moved for help, I'm going to write the wrong answer in red. Here's the wrong answer. Domain X element, whoops, I went to do mapping notation there, Kyle.
Oh, that stands for element?
Element of reals such that X can't equal 0. That is wrong. That was the domain of 1 over X. Range. Y element of reals such that Y can't equal 0. Also wrong. But good thinking. If you don't want to graph, this is the way you got to think. You got to write that down and go, okay, normally the domain was X can't equal 0.
Is it infinite both ways? No.
Yes.
Oh, it is. Fabs.
Greater than or equal to -3.
But now this thing got moved 3 units left. Now what's the domain issue if it got moved 3 units left?
Negative.
-3, because it got moved left 3. So it can be done without the graph. I don't like it. I don't like it. I like the graph. And I'll do the graph in a second. But okay, let's take a shot at range. The range was Y element of reals such that Y can't equal 0. But this thing got moved
So 4.
up, down 4. So Y can't equal -4.
Mr. Todd.
Ugh.
So, is it saying like, is it saying that X can be anything but 3, or is it just saying that X can't be 3?
X can be anything
But 3?
but -3.
But how's it saying that? It just seems like it's saying.
If X is -3, this will be -3 plus 3, and you'll be dividing by 0.
Oh, okay, okay.
How do you graph this thing? Here's how I graph it. It got moved down 4, so its asymptote is now here. I'll draw it in orange. Here's the asymptote. That's how you say that.
So he's just not violent. Wait, is this restrictions though? It's kind of like restrictions.
And then left 3, there's the other asymptote. And then you can graph it. So graphing 1 over X transformed, move the asymptotes. They're literally guidelines to tell you where is this thing. So now there's 1 over X. And if you don't like that, do that investigation to get to know 1 over X better. Now I could do the domain and range. X can't equal -3, Y can't equal -4, and you can get it right off the graph. So can you do it without the graph? Yes. But you got to know what you're doing. If you're stuck, use the graph. Any questions there?
No.
Okay, one question for you. What's going to become difficult here? If you find this pretty straightforward, what's going to be the problem here? I've tried to illustrate what's about to happen.
Maybe like when the 1 is replaced.
Oh, yeah. This 1 gets replaced by a multiplier. If we multiply these things, and then we're trying to juggle 3 or 4 easy things at once, suddenly it's not so easy. Throwing a ball up in the air and catching it is fine, but now if I give you 4, it gets difficult. That's going to be the difficult part, is keeping track of all this.
Well, could it ever be like, instead of the 1 on the top, could it ever be like 2, like...
Oh, it's way worse than that. It could be a 2. It could be a 3. It could be a -3.
That's not cool.
Yeah, lots to come here. Lots to come.
That's kind of easy when you actually listen, though.
Well, so why don't you?
No, like,
Just say that once more.
math's kind of easy when you listen.
That'll be the end of the video right there.